So now let's look at some actual example problems that we're going to have to work through, because that's what you're going to be expected to do for exams and assignments. So first we've got, we're making like an ice cream sundae. So we've got ice cream flavors, we've got toppings, and we've got sauces. So those are three distinct groups. So we've got our group of flavors. Let's see if we can get this pen here to work. So we've got our flavors right here. We've got our toppings and our choices. So we've got these three different things. So since we have three distinct groups, I'm just going to multiply each group together. There were 1, 2, 3 ice cream flavors. That's where we get that number from. There were 1, 2, 3, 4 toppings. That's where my 4 comes from. And then there are 1, 2 sauces. So it's flavors times toppings times sauces, and that gives me 24. The problem is there are lots of different kind of little variations about these problems. So there are a lot of them. They're each a little bit different. So next, we're making a password that's 8 characters long. The first 6 characters must be letters. Side note, there are 26 letters in the alphabet. And the last 2 characters must be digits. There are 10 digits. You've got a calculator or a phone right with you. If you go to type in a number, you'll see there are 10 single numbers, 0 through 9. You can count them up if you want to, but there are 10 different digits, not 9. So I've got my numbers, or sorry, my letters times my numbers here at the end. I needed 6 different letters. So there are 26 letters to choose from, then 26 letters to choose from, then 26 letters, and I was going to choose 6 letters. So 1, 2, 3, 4, 5, 6 letters, and then 2 numbers. I type that in my calculator and it gives me that scientific notation. That's a huge number. That means I'm going to move 10 places to get this whole big number right here. And this is the answer that we're looking for. That's what my math lab is going to want you to put in for your final answer. If you type in the decimal, it's going to mark it wrong. Now I'm going to change this problem up slightly. In my first one, I said that we could repeat characters. So that means I could use the same letter over and over again. Now I'm going to change it so that we cannot repeat them. So now I don't have 26 choices for each one of my letters. Let's say my first letter is a J. Now I don't have 26 choices because J's been taken out. I only have 25 choices. So say my next letter is a C. I've gotten rid of J and C, so now I only have 24. So when we can't allow things to be repeated, no repeating, we're going to see a decrease like this. 26 times 25 times 24 times 23. And we need 6 of them because remember there are 6 letters. So 1, 2, 3, 4, 5, 6. Then our numbers, to start with there are 10 numbers, but if I choose the number 2, I can't choose it again, so there are only 9 numbers. So again, we see that decreasing. And that's because the characters are not allowed to repeat. Again, I'm going to get scientific notation. I need to write my answer out without that decimal if I want my math lab to grade it correctly. Look at another one of these. This time we're getting a Jeep. We have 7 colors and 3 styles. So I'm just going to multiply styles times colors, 7 times 3 to get 21. All right. Next, we've got Kyle has 13 CDs. He has time to listen to 5 of them before work. He doesn't want to listen to the same CD over and over again. Honestly, this question's a little outdated because I don't know who listens to CDs anymore, but it was in our textbook, so, we're going to use it. One key that I knew that he didn't want to listen to the same one over and over again is he said, how many ways could CDs be arranged? So that keyword arranged right here. So that told me that order was important. So that the first was a big deal being first. So that could be 13 times 12 times 11 times 10 times 9. There's actually another way to work this one. So if you go back to our first page of notes, right here, it said permutation, the order matters. So it said arranged. So I could work it like a permutation. So I'm going to add that to these notes right here. So I could work this one. Let me type. I could work it as saying 13 well, you know what? I will just use our pencil again. Oh, here we go. Here's the text box. So I could work it using our 13, get that P from wherever you got it, and I'm choosing 5. So you actually have 2 different ways to work this problem. You can work it the way that I have handwritten out here, or you can use that permutation that we practiced typing in the calculator. The same thing is going to be true for this next one. When we're teaching preschoolers and we're trying to line them up, in line, order matters. So order matters. So I can work it like 9, 8, 7, 6, 5, 4, lining each kid up. Once one person's in line, they can't be first. There's only 8 people to choose from. Once I put the next person in line, there's only 7. If you didn't want to type all of this in, the shortcut is to use that factorial. So you could do that. Or if you thought about it being a permutation, you could do there are 9 preschoolers. It's a permutation because order is important, and we're going to line all 9 of them up. So you could type in any of these 3 and get our same answer. That makes permutations kind of good and kind of bad because you have choices with them. So sometimes that overwhelms people. Whatever comes into your head is the right way. But that also means you don't have to have just one way to think about it. So any way that you think about those problems is going to get you the same answer. The opposite of that is a combination. So here's a combination. Combination, if we go back and look at that first page, a combination, the order does not matter. So it doesn't matter if you're first or second, it's all the same. So let's go back and look at that combination problem. Here we have Jackson has 8 suckers that he wants to give to his friends. He wants to give his best friend, Emma, 3 of them. How many ways can he pass out the suckers? Emma's getting 3 of those suckers. It doesn't matter if she gets the blueberry one first or third, she's still getting 3 of the suckers. So that's why order doesn't matter because her 3, doesn't matter what, she's going to get all 3 of them basically at one time. Or she's going to get all 3 no matter what, however you want to think about that. So it's a combination. There's only one way to work combinations. You have to just work them with the combination button in your calculator. You don't have the choices that we had up here with our permutations. So there are 8 total suckers. He's giving 3 to Emma. Type in that in my calculator. That gives me 56.